So let me get to problem solving with the ChatGPT 3. And I've been skipping this session for last couple sessions when I felt tired. So let me do this. I think I'm gonna group them into two groups. The first group, or problem sets 12 and 13, they are kind of quantum mechanics oriented questions. And then problem sets 14 and 15. That'll be the part 2 of the eventual edited video. And that's more particle physics, nuclear physics oriented set. So let me get to problem set 12 first. And then, so I'll pretend that I'm working through the questions, and again pretend that I'm struggling with it, and I'll seek ChatGPT's help to see how effective it is acting as a virtual tutor. So now I guess I have enough late passes. Let me use late passes and open this up properly. So let me make sure my phone is muted. Okay. So let me bring up ChatGPT. Now this is an academically honest use of ChatGPT. I'm not trying to cheat with it, because by this point, why would I? Basically, any grade I earned is already kind of, well, set in stone is probably too final, but it's not really going to change based on what I do on these problem sets. And so really, I'm working through these questions, hoping to learn physics, and I'm asking ChatGPT for help as I get stuck. I think the first is this interesting. I don't think this is a tutorial. So let me work through it. Particle with the mass m is moving along the x-axis. So let me do it this way. So I'm gonna first put my usual prompt to ChatGPT so that it doesn't just do the entire thing for me. It actually helps me learn. Hi, I'm here. I'm working on my quantum mechanics lower division homework, and I need help with some of the questions, because I'm really trying to learn the material. I am preparing for the upper division coursework, and what I learn here matters actually a lot more than any scores I get. Please help me learn the material by not giving me the whole answer right away. I just want help with the steps I'm stuck on. And it'll acknowledge. And when it acknowledges, let's see. So here, let me imagine someone who has read the hint, and then let's say I see the hint and not quite sure what to do with it. Okay, so for this first question, I see the definition of psi x of and t, and the hint about normalization condition, but I feel so lost. What do I do here? And I'm hoping ChatGPT will give me just the immediate next step, which it should be calculating the psi modulo squared. That's mathematically doable operation, and maybe as you are doing that, you are not sure. So what's this? Am I just multiplying psi to psi? Maybe you don't. This complex conjugate operation doesn't make sense. uh, I hope ChatGPT explains complex conjugate. Yeah. So write down. Yeah. Magnitude 1, time dependence Um, so let's say as you read this, if it made sense to you, then great, you know. But let's say it didn't, or you want to make sure you understand um, what the question is saying. Um, so let me say, okay, on number one, um, I feel like I have to do something with remember that psi squared is equal to psi. Can you explain that for me? And I'm hoping it'll explain the complex conjugate operation. I'm looking for my pen, and I should start writing down. Yeah, what does that mean? Complex conjugate, every I, flip the side, real valued vectors stay the same. Now, if you have any complex symbols, then you also mark them with the complex conjugate. Multiply the two, always real and okay. Apply to your wave function. Let's see. Yeah. So complex conjugate is this, and yeah, the multiply, and this is what I was saying before. The way this wave function is written, you can kind of see that this exponential factor, it'll just cancel out. Um, all right. So I think set up the normalization integral. Let me copy that so that I have it. So with the calculating the psi modulo squared, if the explanation makes sense, then there's probably no point in actually writing down the steps, at least while you're trying to learn it. I mean, sometimes just writing things down helps people remember. If that describes you, then by all means write it down. Here, in the interest of time, let me just move on to the next step. Having read the thing about complex conjugate and everything, I'm pretending making sense. Minus 2 alpha x dx is equal to 1. So this is an integration you have to do. Evaluate the integral. Yeah, you need that. Do you remember the standard result? Um, uh, Try applying the formula or integrate, get a number. Uh, that's a good advice. So let me ask. So you could definitely do this. So, but let's say that feels tedious to you, and you've taken what I've said it to heart. That you can use computer algebra system. So these kind of standard thing, you don't have to do them by hand if you don't want to. So let's say on number 3, evaluate the integral. I remember my instructor saying that I can use um, Sage Math to do something like that. Can you help me with that? And and ChatGPT will give you Sage Math code to do that integral. So let me set up Sage Math cell here, just as a easiest Sage cell dot sagemath.org. I think I finally remembered that URL. As a kind of easiest form of Sage Math you can access. And I think I might actually redo a lot of my lecture videos just using this, not complicated installation of Sage Math. So here's quick Sage Math session or any online Sage cell. It's this one. You can run to evaluate symbolically. So, all right. Let me just, I'm going to ignore the comments because I don't need them. Integrand is x squared times exponential of minus 2 times alpha times x. Result is integral integrand x from 0 to infinity. Huh, is that accepted symbol for infinity in SageMath? Let me give it a try. Maybe it works. After you evaluate, SageMath will return 1 over 4 alpha to the third. Maybe. No, no, no. Missing assumptions? Uh, so oftentimes when you get something like this, the example of a legal syntax works fine. Like the example they give, they usually give the most common example. You do want to make sure alpha is positive. Um, so let me put that in. You could have put it in here. I got an error that prompts me to use assume alpha greater than 0. Does that sound right? Just double checking. It'll probably say that sounds right, and I'll run it again. Yeah, 1 over 4 alpha. Oh, wow. I guess when you do show, it must have some sort of like a verification thing built in, because I think this is an image, or it's some math ML thing. Yeah, the prompt is normal. Yeah, yeah. Assume that. Yeah, that's great. Yeah. I'll say. Yeah, I got that. Thank you. Let me try the remainder of part A myself. So we did the integral. Let's say so the portion of the integral that we did. Let's write this out. Um, so it's this portion here, I think. Let me just make sure. Integrand was x squared um, times e to, yeah, it's this portion, and for that I got 1 over 4 alpha to the third. So a squared was constant, so this whole thing is let me just erase this. This whole thing was a squared times 1 over 4 alpha to the third power, that's equal to 1. So I can solve it for a. A is equal to um, 4 times alpha to the third power on the right. So it's a square root of 4 times alpha cubed. And let's see if units work out. So alpha was given as, oh wait, so what unit do I expect for A? Um, so A times X um, should give me an, I guess, inverse meters. Let me not worry about units. I think a unit will work out right. Actually, okay, this is the unit I'm expecting. Meter raised to power of minus 3 halves, and I think that is right. Because alpha, it has inverse meter unit. So that cubed, so this whole thing, if I rewrite it, it's a 4, um, it well, let me factor out the 4, because that's a square root of 4 is just going to be 2. It's 2 times alpha raised to power of 3 divided by 2 for the square root. So that's, I think, a correct unit. Yeah. So okay, I get A is equal to 2 times alpha. Uh, is that right? I just wanted to check before I plug the numbers. and just keeping track of things that I can come back to. So 2 times x raised to 3 half, and this whole expression I'm substituting in x equals 2.1 e 10 and inverse meter. Yeah, algebra checks out. Yeah, symbol expression correct. So I get 10 to the power of 15. That's good. 6.09. 6.09. It's probably correct. Yeah, good. All right, so we got that. All right, it looks so good. Um, yeah, let's finish up this question. I'm watching my time because I have quite a few problems to pretend to go through at this session, but I think I have enough time to do B, C, and D if I'm not too slow. Uh, so the find the probability that particle can be found on the interval. Um, so so for part B, they didn't give us any hint. Can you give me a hint? So ChatGPT should hopefully just to tell you that you integrate the normalized function modulo squared from 0 to L. That's all you need to do. That's the probability of finding it within that interval, and yeah. Hopefully it just gives you that hint and then stops. It doesn't actually do anything more. Conceptual hint. Yeah, that's it. Um, I mean, I don't. Oh, it might give me Sage Math code, maybe. Yeah, probably that's the definition. Yeah, that's the probability. Yeah, uh, limit. Yeah, yeah, already know it. Good. Make it dimensionless. Yeah, it's optional, and especially if you are using Sage Math. Oh, sometimes it's nice. Yeah, ink tail instead of head. Oh, oh, because elf to infinity, maybe. Yeah, that's interesting. Um, let me give it a try. I mean, so I don't know if I've done it that way in my homework helper videos, but let's give that a try. So, oops, so let's just bring this back. Let's see. I don't really need a result. Let's see. Um, I guess I don't actually need that. Don't need that. So I say tail is equal to integral of x. Yeah, finish off with the. So I'm just gonna put in that factor a squared, which was 4 times alpha to the third power times x squared times exponential of minus 2 times alpha times x. And we are doing the tail integral only. Interesting. 1 over alpha to infinity. Show tail. And I think you don't actually need the numerical value of alpha. It should, yeah, you get a numerical. So you could actually make this a numerical version of tail. Uh, yeah. So 1 minus that, um, 0.323. 0.323. Yeah, and let me just see. I guess if we are, I don't know, head probably, and it'll probably would have been fine. So for head, it would be um, 0 to 1 over alpha, not to infinity. So when you're doing it by hand, I can see the point where sometimes improper integrals with infinity as the limit can, yeah. I mean, compared to this, yeah, the what we had as tail is definitely way more simplified. But if we are, let's see, oh, I guess I should say full simplify. Because I think I already assume alpha is greater than 0. So that could have been simplified. Uh, Wait, that's not defined? I'm a little confused because I thought that was defined. Mm, 1 second. Uh, what's the Sage method command for fully simplifying algebraic expressions? Simplify full? No. I thought it was full simplify. Oh, it might have to be that's interesting. So I have to do it as head dot simplify full. Yeah, then this is something where I can put in through numerical. Yeah. Okay. Thank you for that hint about thinking about tail. That does make the algebra a lot simpler. I tried calculating the head with the Sage method, but that algebraic expression was a lot more complicated. All right. There might be enough time we can spend here. Expectation value position. Yeah. Um, yeah. Let me just do the part D. So okay, I'm done with the B, but I need help with the D. Can you help me set up D? I think I understand the general idea about the operator and how to calculate AEC screenshot. Can you help me set up the Sage math code for calculating as I wrote it out derivative operator? So let me write it out. So let's see. I think the easiest way to do this would be to kind of give myself a little bit of room here. Um, Let me do it the other way. um, or yeah, I think it's gonna be fine. Actually, yeah, let me do it this way. I don't want ChatGPT to be distracted by the whole test to stunt thing. So here, what I need to do is integral from 0 to infinity of psi that. Um, Let me pull out the constant factors out front, which is gonna have h bar squared. Well, there's gonna be minus h bar squared and over 2m, and then it's this portion that I'm pulling out, and then I have the partial second order derivative with respect to x times psi dx. So this should give me average value of kinetic energy. And I'm just asking ChatGPT to help me set up the code. And it should use the expression for psi that we have already been working with. So let me set up SageMath here to try the code that ChatGPT will give me. Um, so A was what? 4 times alpha to the third power. Oh, that's not the integrand. So I should say that psi is 2 times alpha raised to that x exponential of minus alpha times x. And I think a time dependence will still cancel out nicely, so I don't have to worry about it. So for the kinetic energy integral, I'll modify it after ChatGPT finishes giving me answer. I'll worry about h bar squared over 2m later. So it's going to have psi times derivative of psi with respect to x second order, maybe. Let's look what ChatGPT gives me. Ready to run. Okay. X. Oh, yeah. I guess we'll do that. H bar and assume that. Yeah. And normalization. Yeah. It's nice to define it separately. So let me do it that way. Then psi can be defined in terms of a, x, and yeah. And then it's gonna do the second partial derivative separately. We can do that. And now I think it's gonna define, oops, define the integrand as psi times the second order derivative, and then kinetic energy equal to minus h bar squared over 2 times m times integral of integrand. Yeah, that all should be fine, I think. So K is simplified. Yeah, let's look at what kinetic energy looks like before simplification. And then I'm excited to see how well it works out. Yeah, that actually doesn't need any simplification. I think it's ready to plug in numbers. So does it tell you? Okay, I'll say I get this. I get this. Does that look right? Probably right. Yeah. Let me move on to the next set. I don't have a lot of time, so let me pick out a question from the atomic physics set and ask ChatGPT to help me with it a little bit, and then I'll reserve the remainder of the time for the problem sets 13 and 14. So while ChatGPT is answering that, let me go to problem set 13. Yeah, I can just click pass. That's just algebra you should get. Quick sanity checks. Yeah. Yeah, alpha, I guess here behaves like a K. It's not exactly the wave number, but in that wave packet, it serves a role similar to K wave number. So, yeah, yeah. Yeah, I'm pretty sure it wasn't exactly like a K, because yeah, it's not an oscillatory thing, but it's serving a similar role. All right, I think I spent enough time with the wave mechanics. I have to work on atomic physics problems, and let me try to find the. Well, this is a kind of an easy thing, but let's say I made a small mistake of saying possible values of m go from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. It's wrong. I included too many values. Um, and I'll ask. I thought it was an easy question. What did I miss? I thought this was an easy question, but it looks like I missed something. What did I miss? It should tell me that with n equals 5, the largest possible value of L is 4, so that limits m to plus minus 4 at most. Yep. It's the kind of the mistake that someone could make coming in from the Bohr model oriented mindset, and the Bohr model's wrong. Don't stick with it longer than you have to. Uh, yeah, L is limited to that. Uh, so yeah. Oh, right. Thank you. Okay, let's see. Is there a harder question here more than just applying quantum numbers? Might come back to this if there is none. Okay, this is definitely an interesting question. Uh, I think it's gonna take a bit of time, and we've seen ChatGPT help us with the integrals, so I think it's fine. You can get its help, get its help doing the integral with the help of Sage Math. Believe all of you can do that. So let me move on and see if there are other harder questions that don't involve integrals. Orbital magnetic in the 5p state. Let's ask this. So I guess you have to start with recognizing that p means L equals 1. I feel like I should know this, but I'm drawing a blank. Can you tell me where to get started? So once you know L equals 1, then now if you put in 1, it'll say it's wrong, because that's not the magnitude of L equals 1 state. There's the formula. I think a square root of L times L plus 1. So if you put in square root of 2, it should be right. Yeah, P L equals 1. Yeah. 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 Good. Yeah. Bohr magneton already includes all these constant coefficients. So, oh, oh, that explains it. When I put it in one, it said it's wrong. So square root of 2 should be right, right? Is that? I'm pretty sure it's not set up to accept the square root of 2. Like as a, oh maybe, oh it does. Never mind. I thought it was a kind of a thing where I had to, put in an approximate value. Yeah, good. So all right, so that's question 7. Let me see. Um, that feels easy. So let's go back to it. What's it question 4? So let's see. So I'll say this looks like a similar question. Oh, 1.4. That might be close enough. So okay. Okay, so I think this question is a similar kind of a question, and I answered A and B right, but um, I don't really get what C is asking for. So it should clarify that. So you are using the projection with m equals 1. That's the largest possible value of LG. And when it says what is the polar angle, it's referring to the textbooks kind of the model, imagining angular momentum vector as a kind of spinning thing, which is not 100% correct, but correct enough. But it's within that thinking, the polar angle theta is defined. So any momentum quantum number, LG, yeah, let's say this makes sense. Then for largest possible LG, yeah, mx is that. So L1 equal to that ratio, and R cosine to get theta. Yeah, that's it. So let me just do that in Wolfram alpha. Arc cosine of 1 divided by square root of 2. Um, what? That's not 45. Is that 45 degrees? Maybe that is 45 degrees. Oh, 45 degrees. That's larger than I would have guessed. It definitely actually is larger than I would have guessed. Oh. All right, so that's it for atomic physics. Let me just have ChatGPT finish answering it, and when it's finished answering, I'll switch over to problems that's 13 and 14 for just 14 and 15 for playing with the particle physics material. Yeah, good. So this is it for this first half. So let me move on to the second half.